I think we're in a no excuses era. Like, there's no excuses for infra, there's no excuses for regulation. Like, you can just do the thing. Just do the thing.
I remember the craze around frames when it happened. It was a very exciting time.
That was like the very like right curve take on build things people want, and I love it.
Welcome to the Coinbase Developer Podcast, a technical deep dive with top onchain builders in crypto and beyond. I'm Yuga Cohler, engineering lead at Coinbase Developer Platform.
And I'm Erik Reppel, head of engineering for Coinbase Developer Platform.
So Erik, we're recording this on Wednesday, April 16th, 2025, and have recently heard rumors that OpenAI, of all companies, is looking to launch its own social network. It seems like even in the age of AI, we humans can just not escape the urge to post things.
Yeah, I mean, posting stuff is that's what the internet started as, right? Sharing research papers. It's been part of it from the beginning. So everyone takes a crack at it. I'm excited to talk to our guest today.
Totally. And, I think our guest today is really into the weeds of this. Obviously, the fact that these hyperscaler companies like X and OpenAI are all running social networks, using data on those networks to train their models, raise questions around privacy and data ownership. So there's clearly a place for decentralized social networks, the intersection of crypto and social media. Erik, I'm curious, actually, I feel like you have some experience in this space. Do you want to talk about that a bit?
Yeah, funny enough, how I ended up with my job at Coinbase originally was I won the largest hackathon in Canada with a decentralized social networking project. It's still on my GitHub from like 9 years ago. And the idea was like you have tweets and you store them on like a blockchain like structure. I was using Tendermint at the time, which was like the only way to do custom chains. And yeah, as you can see, I've been coding for 24 hours straight. No idea what this is. It goes way back. And then, funny enough, when I joined Coinbase, Varun was still at Coinbase. Not to spoil who the guest is today.
That's pretty amazing. Working on this 9 years ago. We'll take a deep dive in this repo some other time. But yeah, so let's introduce our next guest. So he works on what I think both Erik and I would consider to be one of the canonical examples of decentralized social media. He's the co-founder and CTO of Farcaster, a sufficiently decentralized social network built on Ethereum, and was previously senior director of platform at Coinbase. We are thrilled to have Varun Srinivasan on CDPod. Varun, welcome.
Hey guys, thanks for having me. Excited to be here.
Awesome. So let's dive right in. Tell us, I think we talked about what Farcaster is, sufficiently decentralized social network, but tell us more about what it really is and, things like what are the difference between Farcaster and Warpcast and how it all fits together.
Yeah, so Farcaster at a high level is a sort of public square social network, right? So if you think of the spectrum of social networks, the closest parallel is probably X, where Farcaster is largely a text-based social feed. And, there's a mobile app, there's a web app, and that's kind of how you use the network. But I think it's interesting to talk about what are the things that make Farcaster different. And I think there's three sort of things that set us apart from other networks. The first one is we're open programmable social network. And so the idea is that anyone can build on Farcaster. And the APIs to access data, write data, read are actually permissionless and decentralized in a very strong form way. It's what we call sufficient decentralization. And that's one of the things that sets Farcaster apart. The second thing is Farcaster or Farcaster apps come built in with wallets. And so every user on this social network is actually plugged in and ready to go to do things on chain. And we think that's actually really powerful combined with our third primitive, which is mini apps or the ability to build applications that can run in the context of your social app. And so this is really, really powerful because it lets developers with an idea for like consumer, social, crypto apps to be able to go from 0 to 1 in less than a day. And you sort of like circumvent this whole cycle of building applications. So Farcaster is really social network, wallet, app platform, all in one. And I think if you were to log in and kind of look at the feed today, the sort of geist or the spirit of Farcaster is people who are on the bleeding edge of crypto and AI, who are building interesting things, who very much want to try and experiment with the latest decentralized protocols and the latest technologies. And that's why people use Farcaster today.
That's always been a super interesting like triplet of built-in distribution, built-in applications, built-in wallets to me, because I think anyone building in crypto, like how do you build distribution is like one of the hardest parts of getting off the ground. Is like how do you need a prior to access your app, you need a wallet. I think embedded wallets have started to like make that assumption a little different, but I'm interested in your perspective of like how Farcaster actually gives people that distribution when they're initially launching.
Yeah, I think so. The classic, like, let's say you had like an interesting consumer social idea, right? You have like an on-chain game or something you want to launch. What's the development cycle look like today? First, you go off and you build your app in Swift or React Native or Java or whatever. Then you have to figure out how to embed a wallet into your app. Pretty much every interesting consumer app is usually mobile first, and every app needs a wallet built in because the mobile wallet to wallet experience is bad. So you have this like, I don't know, 10, 15, 30-day development cycle just building that out. Once you're done with that, it's like, okay, now I have to get through the App Store process. And good luck if you have the word NFT, crypto, or anything in your App Store description. Even though Apple technically allows a lot of apps that are crypto forward, the process is sort of arbitrary and you can get kicked out. And once you've done all that, okay, how do you actually get people to use your apps? Twitter's or X's nerfed links. There's no other way to actually get easy distribution. So your only channel is to now go and convince somebody within either you have your own audience or you convince somebody with an audience to post on your behalf with financial incentives or calling in favors. And so the ideation and launch time from like I have an idea to I get my first 1,000 users is like, I don't know, 30 to 60 days for most builders. And the thing we've been really focused on is how can we cut that down as much as possible? And I think we have a really good setup right now with mini apps where if you have a web app that talks to a wallet, you're using WAGMI or any of these modern SDKs to talk to a wallet, you can, with a few lines of code, immediately make it a mini app that works within Farcaster. And this gives you a few very powerful primitives that are useful for you. The first is it lets you tap into our wallets, and we have 80,000 plus users who funded wallets. So without having to build your own embedded wallet, you can automatically get people to do things on chain, and they have balances, and they can interact with your app. The second thing is anyone who installs your app now automatically you have the ability to send them push notifications, which is incredibly powerful. Anyone who's built consumer social will tell you without like in-app notifications, there's no way to build like a good retentive cycle for your users. And so that's something that we give you out of the box and you don't have to go build from day one. But I think the most important bit is the social distribution, where because Farcaster is a social network, you can actually get people to share your app, or more implicitly, when your app is trending, Farcaster apps will actually boost your apps to other users and help people discover them. And so you can go viral through the feed, or you can go viral on the App Store rankings. And that sort of combo of things lets people go 0 to 1 on ideas very quickly. And over the last 3 months, a lot of these pieces have come together recently. So the last 3 months, we've seen like an acceleration in the number of people trying out interesting consumer ideas. And that's been like really exciting to see in crypto, where progress historically has been very slow because of all of these roadblocks.
So yeah, it sounds like, I mean, Farcaster, I'm an avid user. The backbone of it is this sort of network that allows for the distribution. Can you talk a little bit about how much of that is on-chain versus off-chain, how the network is architected, and how that ultimately translates into a feed that the user sees?
Yeah, so let me start with like the highest order bit, which is what do the users see, and then walk all the way down to the protocol. So I think the simplest bit is what is the Farcaster promise? It's that if you build an app on Farcaster, let's say you, Eric, have an app today and I've got one, and you post a message on your app, it immediately shows up in my app. Like instantaneously, the two apps are in sync and everything works together really well. Uh, so I mean, this is sort of table stakes for a social network, right? But it's very hard in a decentralized social network because you're in a potentially adversarial environment. So, Eric's building his app. He's a great, upstanding guy. I'm an evil person. I decide to just flood like 1 billion messages onto the network. And now poor Eric has to sync all of these messages or has to make a decision on what to do with the stuff that I'm doing. And that's kind of like generation one of decentralized social, which is the early attempts at decentralizing social went for the federated model, where they said, hey, everybody kind of runs your own server. We'll come up with some protocol for servers to talk to each other, and we'll make all of this work. That's actually how Farcaster V1 was built. And very quickly, we realized that the problem with this approach is as soon as you have somebody that defects, either they have enough power in terms of resources or users, they can kind of like break the protocol in pretty nasty ways. And that leads to like stagnation or leads to a small group of people being in control of the protocol. And so the thing that we said was like, okay, well, Fine. Federation is this sort of older system. It doesn't really seem to work at scale. It might work in the early days when everyone is playing nice. What about blockchains? Why don't we just do everything on a blockchain? Blockchains have figured out like a couple of core problems. One is they make sure everyone is on the same global state. So there's no difference. There's no like my blockchain server and your blockchain server, right? I run an ETH node, you run an ETH node, we have the exact same data, and that's really powerful. And there's economic incentives that make sure that nobody spams the network. So it's like impossible for someone to come in and drop a billion messages. So we started with this approach of let's try to put things on chain, but we ran into a few problems right off the bat. I think the first problem was, just purely scale. If you look at the most performant consumer-facing blockchains today, Base, Solana, transactions are in like the low thousands or like close to 1,000 at peak. And if you look at like where the next generation is, these are a little more experimental. I don't think there's a lot of like real usage on them yet. But the DAG-based networks are getting up to about like 10,000 TPS and kind of hitting a barrier over there. And if you look at really, really researchy stuff, there's people trying to like sequence multiple blockchains and make different trade-offs and get up to 100K TPS, right? But today we have 1,000. Maybe in the next few years we'll get to 10,000. For a sense of scale, Farcaster, which is a fairly small social network in the grand scheme of social networks, is already over 500 TPS at peak. And if you look at something like X and you measure, every action in the transaction, they're well over, 100,000, maybe even closer to 1 million TPS. So blockchain from a pure scale perspective might get there eventually, but you're not going to be able to build a good social product if you just take a blockchain out of the box and try to make it work. The second sort of problem is the fee model, which is blockchains. Every distributed system is trying to regulate compute bandwidth storage, and the gas abstraction is a way to do that on Ethereum. The challenge that you run into is that storage is very highly priced. Like it costs a lot to store data, and a social network is all about putting data on chain. So it's just like very expensive out of the box. It's not really optimized for storage. And secondly, the model of pay per transaction is sort of antithetical to the what you're trying to do with a social network, where you're trying to get people to post as much as possible. So the idea that like the longer you post, the more you pay, or the more often you post, the more you pay, is just like not going to work for a lot of users. And so what we did is we took the best elements of blockchains. The idea is that things can be in block, the consensus mechanisms, how sync works, but we changed the sort of operational model and the fee model to really fit into social networks. So this kind of gets us to what Snapchain is. And Snapchain is sort of the V3 of our architecture that is really fine-tuned for social data. And Snapchain's goal is to be able to get up to about 10,000 TPS today with headroom to scale a lot more over time. And the two things that Snapchain does, just to touch on it really quick, is one, it says, hey, this is not a general purpose blockchain. You can't do any computation that you want. You can only do a narrow set of social actions, posts, likes, recasts, and so on. But there's like 6 or 7 things that you can do. And the second thing that it does is it changes the fee model to say, rather than paying per transaction, let's do like a subscription style model where you pay once per year and you get a chunk of messages that you can store and that you can send. And for like 99% of users, you sort of think of paying a one-time fee, and then you're able to use the network for the rest of the year without worrying about transaction fees. So those are the two sort of innovations that Snapchain does over traditional blockchains that let us go a lot faster and have a much better UX while achieving all of these nice decentralized properties that we look for.
Yeah, it's really interesting to me. I think like I have friends of mine who are in other parts of like decentralized social, in like the blue sky and other like more federated worlds of DSO, which I think DSO is really only used. I don't think Farcaster's ever really referred to itself as DSO, but it's interesting that a lot of them oftentimes ask like, why are the crypto people so interested in this, and like why are crypto people really, or people with a background in crypto, thinking about this a lot. And it's because, to your point, all the like crypto comes down to this like thinking about economics and thinking about game theory and thinking about like incentives of bad actors and like Nash equilibrium points of minimizing trust in these systems. And so it comes really naturally. And so I'm interested in diving deeper into Snapchain because it's really like the accumulation of learnings for having done this several iterations. And like you said, this is really a V3 of attempting to solve this like fundamental problem of how do you create high throughput, decentralized systems that can handle like true social scale, which is rare for blockchains. It's very interesting that the like logical conclusion is actually go back to Bitcoin and like limit the set of operations that's possible rather than being like fully Turing complete like other blockchains are?
So I've got a Snapchain node running on AWS. I just set it up last night. It takes about 2 hours to sync a full Snapchain node if you run those commands from the command line. And let's just see if our node is running. Okay, great. It looks like it's running, and you can kind of see that, we're in sync because the block delay is around 4. I have this command over here that will fetch all of the posts that I made recently. So let's just go ahead and run this. And this should give you sort of a real-time feed of everything that I've said. Okay, great.
Looks like you have a FID of 2.
Yeah, as the second account.
Yeah.
Number one was the Farcaster account. You guys have something you want me to cast, and we'll see it show up here in real time?
Yeah, can you give CDPod a shout out?
Sure. Um, let me say, excited to be on CDPod today.
So I think this is also the first public announcement that CDPod is a thing. So we're breaking real ground here. It's funny because like all of CDP's secret stuff just leaks on Farcaster, like X402, which is another like stealth project. The only place that's like noticed because we haven't tweeted about it is Farcaster.
That's great. We love having the alpha. Okay, we'll give it a few seconds to go through the pipes, and let's see if it's come through. We might have to run it a couple of times before the message shows up. Boom, there we go. It says excited to be in CDPod today. I actually said with Erik and Yuga, and because I stripped out the mentions, you don't see the mentions in this text. But the full cast basically went from my phone to our backend server to our Snapchain node and all the way to my Snapchain node running on AWS and showed up here in this command line. So it's pretty easy. It took me like 5 commands to run last night, 2 hours to set up, and then you have a stream of all the data that's running on the network.
That's super cool. I think it would be interesting to break down like what engineering actually goes into a node. I think like a lot of people don't realize like a node is like 6 systems kind of glued together. I'm kind of guesstimating 6, but you have like consensus, you have like you have storage, you have like queries. I'd love it if you could break that down a little bit for us about like what actually constitutes the Snapchain node.
Yeah, one way to think about it is the node is doing like a few different things, right? The sort of outermost shell of the node is it's a P2P system that is able to find and talk to other nodes. And we use libp2p under the hood, but there's a fair amount of complexity in peering, rate limiting, and discovering which other systems that you want to talk to. That's the baseline for I'm now connected to the network. The second piece of the node is what we call the authorization or the account layer, which is how do you know that someone is who they say they are? Like, how do I know that Yuga's ID is this or that I trust this message from Yuga? Um, and we actually use some on-chain components here. So the accounts and identity layer actually live on Ethereum, and we've actually sort of outsourced the security of that model down to ETH. And then we also have the next bit, which is, okay, once you understand what accounts are, how do you process operations that people do? And this is sort of the heart of what you can think of as like transaction validation. So once you get past the account authentication, we have these objects called messages. And you can look at what a message is and think of it as like every time you do something on the social network, like post, like, react, you create a new signed message that goes out to users. And there are rules for how these messages are brought in, how they're propagated, and how they update the account state. So, we now have messages, and then we have this notion of account state, which is how do you manage the state of all known objects on chain? That's a little closer to like what you think of as like tries on blockchain and managing all of that. Um, there's some meta things that we can talk about here as well, which is around like how the wrench system works and how the sharding system works. But maybe one good starting point would be the Snapchain white paper. We actually just opened up that site today, and that kind of walks through all things in sort of high level chunks. And I can screen share if you'd like, and we can talk through that.
I was kind of perusing through the code. I always think it's interesting to kind of like walk through the concepts in code as well. But maybe we can start here, and we can even hit on a couple of the things that are like in the code base and map them out.
Yeah, we can talk through that. I think it's a little more verbose, given that it's in Rust, and so
Yeah.
sometimes the concepts are a little more succinct here. But if you sort of skip down to like the first section, which is accounts, I think um, the way to think about Farcaster's account state is people create and manage accounts on chain. So, step one is you have a wallet. you create an identity and you're able to use that identity. And, in an ideal world, we would just use wallets everywhere. But the challenge that you run into is like people change wallet addresses all the time, right? They're not user friendly. And for a variety of security and privacy reasons, you may want to rotate them. So they're not a good durable identifier. And if all our follows were established based on wallets, then every time you shifted a wallet, you would immediately lose all of your followers. And that would be really annoying. So we introduced this sort of intermediate identifier called an FID, which is a unique numeric ID that you get, you put it in your wallet, and every time you want to change your wallet, you can just sort of like nudge this FID around between wallets, and your identity follows you everywhere. And so everyone's relationship to you is based on this identity. Now, obviously, this ID, you don't want to be like at 56789. Like you want a human identifier. So we have usernames on top of it, and we use ENS for username. So there's different kinds of ENS names you can use. But again, you sort of have the same problem with usernames of like, you can't use them as the permanent identifier because people change names. They want to upgrade their names. Brands rename all the time, and you can't lose all your followers. So this FID intermediate construct actually binds a name to a wallet temporarily, but it's your permanent long-lived identifier, and you sort of establish that on the blockchain. And if you go up to section 1 in sort of the white paper, there's a diagram there that walks through like how that mapping is done. And there's this set of contracts on OP mainnet called the Farcaster registry contracts that take your Farcaster ID, they bind it to your custody address, which is the primary address that says you are who you say you are. And they also bind it to some additional metadata, like a recovery address that can help you recover an account and some more app keys and other things that can be used to authorize applications to post on your behalf.
It's interesting that these contracts are an OP mainnet. Some of the security you're relying on Ethereum L1, and as we'll get to later, I feel like a lot of the apps, mini apps, are actually on Base. How do you think about like what networks to use for which purposes, and if there's any fragmentation about which parts of the architecture rely on which blockchain networks?
Yeah, the honest answer is to build a registry, you just need a blockchain that you trust to have good security properties, that is cheap, and that is fast. And so you could build this on any Ethereum L2, you could build this on Solana, you could build this anywhere you want. And I'm actually not convinced that the location of this registry is like that particularly important, right? Like most people think of Farcaster as a social network that's associated or linked to Base, even though our contracts live on OP mainnet. So the contract's almost invisible to most users, and we've built, gas abstractions and all of this stuff so people don't have to think about where do my contracts live. In terms of what do we support from an application perspective, we actually want Farcaster to be as neutral and as agnostic as possible and say like, hey, if you want to build an app that runs on Base or an app that runs on OP mainnet or an app that runs on Solana, like you should be able to build that using the open social graph. And like, that actually helps all of crypto kind of work together and rise together. And where the registry is doesn't really matter to where it supports. Now, the practical realities of supporting different chains are you have to have different indexers, different sort of infrastructure. And so we can't support everything on day one. So today, Farcaster has the best support for ETHL2's Base, OP mainnet, and so on. Some limited support for Solana where you can have verified addresses, and not a lot of support for other chains as it stands right now.
Makes a ton of sense. One last question on Snapchain before maybe we can pivot to like talking about how different types of wallets are integrated into Farcaster. With ETH L1, you get a lot of conversation around state permanence and especially with archive nodes, which take a long time to spin up. As Farcaster scales, and if it's successful, it's going to scale beyond 500 TPS to thousands, tens of thousands, hundreds of thousands of transactions. Like, is there any concern that if Snapchain is storing all this content on its node, that as the network becomes more successful, there's going to be bloat? And like, have you already sort of planned an engineering roadmap for that?
Yeah, so one way to think about it is like, okay, what are the actual constraints on Snapchain nodes? And so the way we think about Snapchain nodes is unlike Ethereum and Bitcoin, which are like, hey, we want this like massive fan out of different nodes running on different machines for security. Well, we actually use Ethereum for the core security of accounts. So we're really trying to decentralize access and availability of data, which is a slightly different problem. So our trade-off is we can use large cloud boxes on AWS. We don't need 10,000 nodes running to guarantee network security. Like 100 nodes are actually probably sufficient for our purpose, even though we have a lot more than that today. And so the sort of upper bound constraint you have is how big are the boxes on cloud providers, AWS or whatnot. And so you can think of this as like bandwidth, storage, compute. Compute, because of Farcaster's limited set, is not a big constraint. But you guys, you sort of pointed out, storage ends up being like one of the bigger challenges for how do we fit stuff on a disk. So the mental model we have right now is the upper bound for storage is, call it 64 terabytes, somewhere between 32 and 64 terabytes of like what you can get on a single machine. That's when you're going to start having problems with nodes. So the way we deal with this is like sort of multifold. The first is this notion of state rent or storage rent, where we actually charge users for storing data on the network. So this immediately imposes a cost. You buy 1 unit of storage, you now get to store, call it 2,000 messages. And if you want to store more, you have to pay. And this gets more expensive over time as utilization increases. The second thing that we do that's interesting in the context of a social network is if you exceed that limit, we don't just say stop, you can't use the network anymore. We actually just prune your oldest messages. And for a public feed, that actually ends up being a reasonable user experience for like 95% of people. Now, there's going to be some set of people who are like, I want a longer history. And again, they can pay for additional storage units and preserve, 2,000, 4,000, 10,000 messages if they would like. So that simple thing sort of adds this layer of economic limitation to the network. Now, the network is about like 170, 200 GB right now. So we have, call it quite a like 100x plus scaling throughput just on like a single machine. But to go beyond that, we actually have this notion of sharding, which we kind of go over in section 6, where one of the reasons we elected to keep the operational model very simple and just have these narrow opcodes is we can achieve perfect sharding in a way that traditional blockchains can't. And the reason is that, like, Yuga, if you send $10 to Erik, $10 of USDC to Erik, and Erik sends it to me, I need to know that full chain to be able to verify that my account balance is $10. There's like a lot of interactivity between these operations. But if you think about a social network, there is no interactive requirement to doing most actions on a social network. The simplest example is, hey, I post hello world, and I don't have to check anyone else's state. I can just check my state on one machine and post it. And so the idea that like my data could run on one server, Erik's data could run on another server, and Yuga's data runs on the third server is totally viable in this world. And a common thing people say is like, oh, what about replies? Like, what if you reply to Erik? How do you validate all of that? And the interesting thing that it turns out is you actually can't validate across objects because let's say Erik says hello world and I say welcome, and Erik deletes hello world. There's always a case at the application level where messages can get deleted, and messages are valid even if they reference other messages that no longer exist. That's like actually a normal state of operations. So we never validate like a full reply chain. We just say, hey, you responded to something Erik said. I have no idea if what Erik said was true or is even still active, but if I find it, I can render it as a thread in the app layer. And if I don't find it, I'll just show it as a missing object. And so the side effect of all of this is like we can technically, put each user on their own separate machine if we wanted and like perfectly scale it out. Now, obviously, that doesn't work in practice because of practical speed of light networking constraints, but you can easily reach 10 to 100 shards and get, significantly higher throughputs than what you do today in a way that blockchains can't because they have to have this like much more expensive inter-shard communication to make sure that these cross-chain transactions are all working in sequence. So that's kind of how we think about going beyond the 1,000 TPS or 2,000 TPS and reaching the 10,000 TPS architecture with this design.
This is kind of like a very minor nip, but it's a thing I've been curious about is like when you have a shard in Farcaster, is it that the node is sharded or is the content sharded across? Is each node treated as a shard and then content is distributed across each like node?
Yeah, it's a good question. The simplest abstraction to think about it as you can think of Farcaster as, and to be clear, we have one shard today because we haven't hit the scaling limit on a shard, but we have a design that allows us to scale. But the way to think about Farcaster is it's a chain of k plus one shards, where there are k shards that you rotate each user's content around. So you can do a simple round robin and say everyone whose ID ends with one is on the first one, second, etc. And then you have one sort of chain that binds them all together and says, hey, this is the block that was produced. I have a shard from chain 1, chain 2, chain 3, chain 5, and this is the meta block. But the abstraction that we expose outside to other nodes that are not part of the block building process is, hey, here's the next block. And you don't have to think about like different chains, different shards. You get one block. There's sort of, k slices in that block. Each has a slice that was validated by a different machine, and you just consume that as a single block and move on.
Interesting. It almost treats like the entire network as like a sharded database where each node represents a shard rather than the node being sharded.
Yeah, this actually borrows a lot from Near Protocol's design. That's actually what inspired this original version. Ours is a significant simplification because we don't have the cross-shard communication problem that Near has. But the idea of slicing blocks and having these validators build things in sequence came from that white paper.
Super cool. Yeah, Near has some really interesting tech in it.
Maybe we can pivot to a topic that's very near and dear to both mine and Eric's heart, which is wallets. So yeah, tell us so obviously every Farcaster user has a wallet, which I think manifests in the Warpcast client, but talk to us about the wallet infrastructure that you guys use.
Yeah, and by the way, congrats on the launch of the new wallet product. It's actually very, very exciting to see. I wish we had this a year ago when we first started building out our wallets, but I'm very, very excited to see where it goes. The I think the high level, the thing that's sort of becoming obvious now in the crypto space is that every app is going to have an embedded wallet because mobile matters and cross-app communication on mobile sucks. And so I think the state of the future is everyone will have a wallet. We'll figure out some way to move stuff across wallets and do permissions, but this is like a no-brainer. We ran into this on Farcaster where for a long time we tried to like work with all the different sort of wallet interop protocols. We worked with the one that Coinbase had. We worked with the Wallet Connect standards, but I think there are fundamental OS limitations that just make it really, really hard to try and do things with a protocol, and you have to like embed into the application. And so the way we've built it into Farcaster, we use Privy today. And the general idea behind our wallets is that we want to focus on the best user experience and make them available on both mobile and web. Mobile tends to be a lot easier for secure wallet access because you have passkeys, because the mobile environment is generally more secure and more robust than a web environment where it's just like, you just run into more problems with extensions, you don't have a secure way to store data, lots of these other problems. And so the
Passkeys
way.
doesn't guarantee good experiences. Yeah, Yuga and I have a lot of thoughts on passkeys. We'll have to
Yeah,
we'll talk. We might talk about that on a future episode. But sorry,
I
I
fully
didn't mean
agree
to.
with that. I think there's a bunch of folks that say like, hey, passkeys magically solve all problems. And they are magic like 60 to 70% of the time. And then there's a long tail case of 30% where they don't work quite as well. And that there's a lot of issues that still happen. But to get back to the way Farcaster wallets work is we actually use Privy, as I mentioned, and do this sort of Samir's secret sharing where we split the wallet into multiple shards so that some of the shards are controlled by the user, some of the shards are controlled by Farcaster, and some of the shards are controlled by Privy. And so two of three have to come together to actually reconstruct the wallet. And the nice thing about this is you can reconstruct it on mobile. If you log into web, you can reconstruct it on web. And we actually use your Farcaster identity to authorize access to the wallet. So we verify this like Farcaster signature. It's actually a sign in with Ethereum signature. And then you get access to one shard of the wallet from one provider, and then you can build and reconstruct your wallet. So as long as one of Farcaster or Privy are operational and give you the shard, you can always reconstruct your key as long as you have your key shard. And you can also, of course, export and back this up in a more traditional way to a passkey or a wallet if you want. So it hits this nice point of you have wallets working on mobile, which we have today, and wallets that'll work on web, which is coming soon. And you also have the ability to export and do whatever you want with your wallet.
Can you talk a little bit about that sign-in with Ethereum standard? Like, what is the authentication material that's being used, and how's that generated in order to enable that key shard on the user's device?
Yeah, so the core of how Farcast we have this notion of Farcaster authentication. It's the equivalent of sign in with Facebook or sign in with X. And it's built using the sign in with Ethereum standard. So if you produce a sign in with Ethereum message, valid according to the spec, and you include some particular data saying, hey, I'm authorizing, this particular app, I'm authorizing my account to sign into this app, then that app says, okay, I now trust that you are Yuga, and I will give you access to the app as if you were Yuga. At its core, it's just a C-way message, nothing fancy. We have built some infrastructure around it that we call Farcaster Connect or sign in with Farcaster that just makes it easier to transport those signatures and also transports metadata. So if you get a valid message, you would also get like a profile picture and a bunch of other stuff, but it's still signed in with Ethereum at its core. And so this is validatable independently, right? Like any third party can take this, look at the blockchain, say, hey, let me look at the contracts, let me see what account this is. I now verify that this is actually from Erik or from Yuga, and I can give you access. And so that is the auth mechanism that underlies how you get access to the wallet. and the auth material lives on the user's device. We've actually built, so if you use the Farcaster app today, for every user, we set up a wallet and we load that wallet into the user's passkeys. We actually hacked this before account abstraction was available. We use this property on passkeys called large blobs to actually stuff and store the ECDSA key very securely. And so we've had this working for like a couple of years now. And on iOS, it's been really, really powerful. So you start with this secret that the user has on their device, or that's backed up in a seed phrase if they don't have passkeys, and you use that to authenticate into a wallet that can port between all different devices. So you have this like self-custodial property, but ability to move quickly between different platforms.
That's super cool. And then I think this is like a natural point of like to talk about mini apps, because I think that the power of having a wallet on every client is that you can now do things on chain. And so I my understanding is that like mini apps work because the wallet signs transactions, and I think can even broadcast transactions for these mini apps. But gut check me on that. Maybe you tell me how that works.
Yeah, so the mini app standard, this has actually been an evolution over the last year. And I think it's worth talking a little bit about the history. About a year ago, we launched this building block called Farcaster Frames, which was a way to take, traditional embeds, which are like an image and, a little bit of text and a description. You see that on your, Twitter feed or Facebook feed, and make these interactive. So we literally just added buttons to them and the ability to generate multiple embeds that link together. And it was really successful early on because we saw people being able to do on-chain actions with these objects. Like people were basically making it so that when you click the button, some server, on base or another L2 with cheap transactions would send you something. And so it became this like aha moment of like, if you made the feed interactive, people can link on-chain actions to it. And that opens up this whole interesting space of ideas to explore. The problem with frames was that they were very, very limited in what they could do. Like it was literally an image and a button, and images were hard to generate, and you couldn't do a lot of like more sophisticated UI. And I think the things that we got really excited about unlocking in crypto, things like games, things like more sophisticated trading apps require much more complex UI. And so we slowly evolved that standard of frames, and it became closer to what is a web view. And so what frames are today, or mini apps as we call them, are basically a web view that load from your website. So you're loading exactly your website and your application into our context. And we give you two things. We give you some pointers to say, hey, this is the user that logged in. This is, you're now rendered in a Farcaster context. So your website can sort of flag and do different things. And then we inject a wallet provider into your context that you can call and use. So this is, a WAGMI provider. And if you're using WAGMI to talk to, your wallets in the browser, you can just use them natively here and send transactions and request transactions and do all of the common things that you do with the provider. And they will just work out of the box. We handle the UI, we handle the execution. If the user doesn't have gas, we tell them how to get it. We magically do it in cases that we can. And all of that transaction execution, you don't have to worry about. You literally call an API that says swap X for Y or send, X to Z, and Farcaster apps will handle all of that execution layer for you. In addition to that, the last sort of thing is we have some other SDK objects that let you do more one-off actions. So you can launch someone's profile or you can send a direct message to somebody. So there's like a handful of these direct actions that you can also invoke from the SDK that plug into the more social component of what these apps are able to do.
Yeah, I remember the craze around frames when it happened. It was a very exciting time. And I was playing around with it. I remember it used to be, it was basically based on the Open Graph standard, and you could build a frame based on a bunch of meta tags, which made sense because I think one of the purposes of that was to purposely restrict the possible actions you could do, because if you can inject arbitrary content into Farcaster app, that raises a lot of security concerns, right? So like that's the traditional concern around like iframes. So how do you guys ensure that these new mini apps also aren't super vulnerable to some of the security concerns that might result?
It's a great question, and I think that's one of the biggest challenges in building mini apps and building clients that run mini apps. On mobile, they render inside of WebView, which is slightly different. It's sort of the React Native web view as we use React Native components, and on web, they render inside an iframe. By default, both of these primitives have pretty strong security isolation guarantees in terms of being able to like keep execution items there separate from what's executing on the main thread, and you get like decent properties of like, hey, this thing just can't escalate and do things. That being said, they're very, very complex objects, and there are a lot of configuration parameters, and there's lots of libraries that you can use. And obviously, this is JavaScript. And so you have a lot of, there's a lot of danger with things like prop pollution and so on where you can exfiltrate. So we spent a lot of time doing security audits. We're actually going through one with the Zealot team right now and really working hard to make this robust. And so the sort of simple and complex answers, the simple part is they work. The complex answer is you have to invest a lot of time in dialing and fine-tuning all of the parameters to make sure you didn't introduce a gap or a bucket somewhere that could cause an escalation out of that.
Yeah, it's kind of, it seems to me like one of those, like, you just do it through rigor and good engineering practices and discipline, and you know, you just have good security posture, and it's like as much or more of like a Web 2 security issue than it is a Web 3 security issue. It's like all
Yeah.
the problems of like Web 2 embedded content, but also you could, you know, you have access to a wallet, and so that is bad if you have access to that thing. We ran into a lot of
And
this with Zora because we had embeddable HTML, like mintable HTML, and so you could run HTML in like the mint window on Zora, and so we had to do like a bunch of work to like make sure that was securely isolated. But it meant you could do like cool like D3 mintables and all sorts of like, people did all sorts of cool stuff with it.
yeah, the team's actually working on a pretty cool for the web wallet, they're working on a pretty cool like bridge proxy model where you can actually isolate all the interactions and pass them through a very narrow set of APIs. And we're probably going to open source that sometime soon so that it's easy for other people building apps just to inherit and build on those primitives. I think web has always been a little trickier and more challenging than mobile. And so hopefully that will help more people build mini app frameworks into their apps.
Looking forward to reading the code there. That'll be super valuable for the industry, I think, to have a good reference on that being open source.
We're coming up on time, so I wanted to ask a few sort of up-level questions about how Farcaster operates. One thing that I've always seen is like, you know, every so often I'll see a post from you, Varun, or your co-founder, Dan Romero, about, hey, we are hiring one staff level engineer. We're a team of like 6 engineers running this decentralized protocol. Hiring is top of mind both for Erik and I for CDP. You know, getting top talent is frankly pretty challenging, but talk to us a little about how you've built out your engineering team. Like how large or small is it? How much responsibility does each engineer have, and like how you hire?
Yeah, so we're a fairly small team, as you mentioned. We're about 16 engineers right now, and we've been very, very lean for the life cycle of the company. Like last year, we were probably half the size of this, and a year before that, we were like 4 people. Our philosophy has always been to hire fewer people and make sure that it is painful. Like you always want to be at a stage where you're like, I wish I had 3 people, and that's like the right place to stop. Because when you have exactly as many people as you need, you've probably overhired. And I think the other thing that has sort of informed our thinking about hiring and why we're so aggressive about staying lean is, Dan and I were at Coinbase from 2015 to 2019. I mean, Erik, you were there as well. We saw a lot of the challenges that come with hypergrowth and with adding too many people. You end up trading one set of problems, which are technical or execution problems, for a different set of problems, which is coordination and management problems. And I fundamentally don't like that set of problems. And the trade-off that you can make is you can basically cheat and say, hey, I'm going to hire more senior people. Like they generally tend to be more independent, and sometimes one person can do what would take 2 people to otherwise do independently. And you can also just give people a lot of autonomy and freedom and say operate. And so I think that we operate as a 16-person team in many ways achieve what other 30 or 50 or even larger person teams accomplish because we have been very rigorous about the staff level and we've been very rigorous about the process. And it really comes down to that's just the style Dan and I enjoy operating in. There's nothing inherently wrong about having a larger team of more junior people. In some ways, it's easier to hire. In some ways, it's like more fun because you can like, potentially be like in an office and working together and things like that. But the trade-off that we made is we wanted to be remote. We started in the pandemic and that was sort of forced upon us. And we said that the trade-offs of that are we will hire very senior, we will stay very lean, and we will build a company in this particular way. In terms of how we've grown the team, I think, again, startup hiring, I think, is very different from hiring when you have a large brand like you do Coinbase. And so we've hired almost entirely from our network and people that we've known and worked with, many folks from Coinbase that we worked with in the early days. And that's been the sort of core of our team. And more recently, we've actually had some success branching out and actually getting in net new people who come from other industries or other spaces and are curious about crypto. And we've actually had some success also bringing in some folks who are more at the senior level. Now that we've had a good baseline of staff level talent, we're actually able to absorb one or two folks who are a little earlier in their careers and growing. And that's actually been like a nice change over the last couple of years.
That scale hiring thing is always a trade-off. I think you and Dan also left before Coinbase really like hit the gas on hiring and growth. Um, we try to ask this to everybody who comes on the show. What do you think is the? It's kind of a triplet of questions, and I'll give you all three of them, and you can slice them up however you want. It's what do you think is the hardest part about building in crypto? What's one thing you'd love to see advance in the crypto industry? And what can CDP do to help accelerate builders?
I think the answer to the first question, what's the hardest part about building in crypto, has been um, the challenge of building without like clear regulation. I think it has actually just made it super hard for people to build interesting products, and conversely, super easy to build like more scammy products. And I think that's just been like a net bad for the industry. It's like changed the perception of what people are building. It's like made it harder for good builders like Coinbase to be successful and made it much easier for bad actors to be successful. And the good news there is I think that that's changing. I think we've slowly seen a shift in regulatory approach from like, we're not going to talk to you, we'll just sue you, to we're actually willing to work with you and come up with structures and frameworks. And I think that is the biggest problem today, but it's changing so rapidly that I don't think it will be a problem a year from now. What is the problem that is apparent right now? I think I actually think like most of our infrastructure problems are solved and most of our regulatory problems are about to be solved. This is not to say don't build any more infrastructure, right? Like we still have to make blockchains faster, but it's no longer the thing that's holding us back. And I think the unfortunate but simple answer of like what is the biggest problem is most people are not focused on making something people want. It's like the whole simple YC thing of like just figure out what the users want and build it. That's all there is to it. There's nothing more, nothing less. And I think we have for so long had this like narrative of like, you had to communicate that you were a protocol in order to raise venture money. You had to like structure your company a certain way to avoid like certain regulatory challenges that people have sort of like, they just assume that's the normal way to build companies. And we're like cargo culting into all these things that don't really matter anymore, instead of like a return to the roots of we have fast infrastructure, we have good regulation, just like what do people actually want from this stuff and how can we ship it as quickly as possible. And I think unlearning a lot of those lessons that have been forced on us is like the biggest problem the industry faces.
That was like the very like right curve take on build things people want, and I love it because I think you're right. Up until recently, it was impossible to have the left curve of that same take of just build what people want. And I think like as an industry, we got to like shift people from the middle of you must have like a complex structure and you must like innovate a blockchain and you must like have all these like fundamental infrastructure problems solved before you can deliver something that people want. So that was great.
I think we're in a no excuses era. Like there's no excuses for infra, there's no excuses for regulation. Like you can just do the thing. Just do the thing.
What could CDP do to help advance builders?
I'll give you the answer from the perspective of Farcaster developers. And I think the core problems that we run into are one, wallets. Like how do you generate and secure a wallet? And I think we have with great difficulty built out wallet infrastructure that works and secured it by combining a bunch of different providers. But like cheap, easy, safe wallets that are like, Web2 API level plug and play, I think are super important and are going to be very needed. Second thing I think is data providers. We use like so many different data providers. They're shutting down left and right because it's like actually like kind of a hard business to monetize. And um, it's not as simple as it sounds. People are just like, oh, indexing data, that's so cheap. Like I think they over trivialize it. Anyone who's actually built data understands that like it's actually about filtering out bad data, putting in good data. Like if I want a list of tokens, how do you filter out like the junk tokens and give me like an interesting list? It's such a nuanced problem. And I think we're still scratching the surface of what needs to be done there for tokens, NFTs, and other chains. That data, just data APIs are a big problem today. And then I think the last thing is like safe execution. You can sort of think of this as transaction scanning. You can think of this as like, moving funds between wallets, but there aren't a lot of providers anymore. Like one of the providers we used to use actually shut down. And so the idea that of like, how can you take a transaction and make sure that it's safe before a user executes it is another very, very important API that needs to exist. And the last fourth point is on-chain, like funding or onboarding wallets. I think it still really, really sucks. Like we've tried so many times in so many different APIs, and I think our success rates are like, and we've talked about this before, Eric, but our success rates with all the other parties have been like less than 50% most of the time. And if you sort of ask me, like, what should CDP do? I think, well, these are all four problems that need to be solved. But I would kind of think about like, what is Coinbase uniquely positioned to do way better than anybody else? And I actually think it's that fourth thing. It's the like, how do we get onboarded funds? Because Coinbase is literally the best in the world at this, at fraud prevention, at regulation, at figuring out the right trade-offs and the knobs and dials. And like the retail product does this so amazingly well. If we have some version for that for on-chain, it would be incredibly powerful. And then the side effect or the exhaust of that is if you do end up doing KYC or limited amount of KYC to help users, you can also let them put that on chain. And I think that's going to be a super important primitive because all these apps are now like, okay, I legally can't serve users in some regions or I have some restrictions. How do I actually do this? Check Cloudflare, this, that is all very messy. And so I think you have this like incredible ability to take what the retail product has built and turn it into a developer building block in a way that nobody else can. So that's probably what I would think about if I was in your guys' shoes.
You got to stop leaking our roadmap, Varun.
Yeah, I was just going to say thanks for dictating our product roadmap, Varun. That was incredible.
Thanks so much. You guys think you got to wrap up?
I think we're up at time. So thank you so much, Varun, for taking the time to talk with us. For those of you listening to the podcast, check it out at, I think there are a number of websites. They just published their white paper. I think we can have a link to that, github.com/farcasterxyz, farcaster.com, also warpcast.com. Check out the client. Any other links you want to shout out, Varun?
Cool. I think maybe the two links worth shouting out for developers are snapchain.farcaster.xyz and miniapps.farcaster.xyz. I think those are the two best places to get started if you're like, hey, I just want to learn how to build stuff.
Awesome. Cool. Well, thank you so much for joining us today, and we'll see you on Farcaster. Lead the world's transition on chain by building with Coinbase Developer Platform. Visit us at cdp.coinbase.com. Follow us on X at Coinbase Dev, and be sure to leave us a review on your favorite podcast app.